I'm Michael Langguth,
I'm Mary Peterson.
and we worked on internal flow using SolidWorks. To begin, we did the same sweep function we used for the horn to create a section of pipe. This is a velocity increaser. Velocity is water is supposed to come in here at 5 meters a second. Since our area decreases, or diameter decreases by half, our area increases or decreases by a quarter, and our velocity should increase to 4 times that rate. Now, to set this up, initially, after you make the pipe, go into make sure you turn on your flow simulation software. Click on New. You want to open up your general settings here. This is where you can add in all your time constants. Make sure you're on internal flow. You can set up gravity. You can make it time dependent. You can allow heat to conduct through your pipe if you want here. You can also change your fluids. If you want to use different fluids with different viscosities, it'll show you different boundary layers against the walls. You can also change your wall conditions to add rougher walls, simulate different materials you're using. And this is also where you can set up your initial pressure and velocity conditions. Go down here and hit apply, select OK. Next thing we want to do is set up our boundary conditions. On this we have set up an inlet velocity. You come down here, you set up, click your inlet velocity. You want to make sure you select the inside of this cover. When you do internal flow, these need to be closed structures, so when you open up a new project, it's going to ask you to close these pieces. It'll open up almost like a wizard for you. You zoom in, you want to select these faces, and it'll create a cap to close these systems off. Now you want to make sure you select the inside face of that, hit OK, and then we did the same thing, put the environmental pressure up top here so it's not affected by anything, it's just allowing the fluid to flow through the pipe naturally. We want to set up our goals so that we're just calculating a max velocity. This is what the program's trying to converge to as we're using it. If you set up too many of these goals, it's going to try to converge to each one of them. It's just going to basically waste your time trying to run a lot. Once you run it and get your results done, you can come in here, set up your flow trajectories. You can change them. You can change them to any parameter you want, really. Leave those at velocity. Select the number of pipes you want to see running through there, the thickness of them. Hit OK. Now you can see that we start roughly around right about 5 meters per second, and we increase to right around 20 meters a second, which is what we wanted to see. And then if we go and turn that one off, turn on a cut plot. This one's been set up to show you the pressures. Now as our velocity increases, our pressure needs to drop, which you see here. And as we drop down in our pipe using Bernoulli's equation, as we lose elevation, we need to gain pressure, which you see happening here, and we make the corner. And as we start gaining elevation, we begin to lose pressure. Again, be careful with all your goals because you don't want to run this thing too much.
I did another type of pipe. The geometry can be seen here, and when hand calculating what the final velocity at the top here should be with an input velocity of 10 meters per second down here, I came up with an answer of 38.51. When I ran it in SolidWorks, it told me that the final velocity was 34.55 meters per second, which gives us about a 10.3% error. And SolidWorks has a nice way of presenting these in a goal plot, which I will show you. Also, like Michael, I set up boundary conditions and inlet velocity down here, 10 meters per second, and at the top I left it open to environmental pressure. The goals I told it that I wanted it to find were the maximum velocity within the pipe and also the final velocity at the face at the top here. I also did a cut plot, however my cut plot is just showing the velocity in the different colors, kind of a nice visual way to see all the different velocities in the different areas of the pipe, and also did flow trajectories. Now with this scale you have to be careful because you can accidentally drag this arrow and then it'll change the color scale and show you 30 now as the maximum velocity and show you the red region where all the velocity is equal to or greater than 30 meters per second. However, I want it to show me the maximum velocity being the red color, so I can click on the arrow and click this auto scale button. and then it brings the maximum velocity to be that nice red color that you see there. Then I went and set up some goal plots, and I wanted it to show me again the maximum velocity in the pipe as well as the final velocity at the top face here. And once you select which goals you want it to report, you can have it export to Excel for you, and it will pop up in a nice chart like we see here and show you averages, minimums, maximum values for each goal plot that you asked it to present. And that is just about the gist of internal flow.